Math 1332, Chapter 2, Set Theory, Section 2, Subsets and Set Operations, Video 8, Set Subtraction, also known as difference of two sets. So far, we've learned three set operations. One, a unary operation, taking the complement of a set within a universal set. 2 and 3 are binary operations, the intersection of two sets, meaning what they have in common, and the union of two sets, meaning that we join two sets together to make a larger set. Well, usually larger set, but it can't be smaller. Well, what do I mean by set difference, which sounds like set subtraction, because it's the same thing. Well, we have the definition right here, so let's take a look at it. The difference of two sets A and B, written as A minus B. Now, before we go any further, the order that you write a set difference in matters because the order that you subtract things matters. For example, if we were just doing a regular subtraction problem and I said 5 minus 3, you all should say 2. But if I turn it around and give 3 minus 5, that's not 2. 3 minus 5 is negative 2. And the only reason I'm pointing that out is because when you switch the order of a subtraction problem, you normally don't get the same answer. The only time you would get the same answer if you were subtracting the same number from itself. So when you're doing a set difference, a set subtraction problem, it's really important to pay attention which set is written to the left of the minus sign and which one is written to the right of the minus sign. But let's continue. The difference of two sets A and B, written as A minus B, is the set of elements that are in set A but not in set B. Let that sink in for a second. The elements that are in set A but not in set B. If we were to write this in set builder notation, it would look a little something like this. A minus B is the set of x's such that if we're going to say x is in A, that means x is an element of A. And at the same time, x cannot be an element of B. So it belongs to whatever belongs to the first set but doesn't belong to the second is in our difference A minus B. Now, where's the subtraction nature of this? We're just saying you belong to one thing and not the other. Well, you'll see the subtractive nature of set difference with the way I'm going to show you how to calculate them. All right, so we're going to consider the following three sets. We have set A, which contains the letters P, Q, R, S, and T. Set B, which contains the letters R, S, T, U, and V. And set C, which contains the letters P, R, T, and V. Now we're being asked to find the following 6 set differences. A minus B, B minus A minus C, C minus A, B minus C, C minus B. All of which are pretty easy once you have a strategy. So what's that strategy going to be? I'll tell you what that strategy is. The strategy for calculating a set difference is you first write the elements of the first set. So let's go ahead and do that for A minus B. The first set is A, so we're going to start by writing the elements of set A, which are P, Q, R, S, and T. Okay. So what do we do after that? Well, our set difference contains everything that belongs to the first set but not the second. So we want everything that's in A but not in B. So let's start with everything in an A, but we want to remove the ones that belong to B because remember, the definition says it can't be in the second set. So one at a time, we have to ask ourselves, do you belong to set B? Do you belong to the second set? And if you do, we cross you out. And that's going to be the continuation of our strategy. Then cross out any elements that also belong to the second set. And we can literally grill them one at a time. trying to get rid of the line break there. Make sure it doesn't run into my face. All right, so you start by writing the elements of the first set, which we did when we wrote the elements of A, but now we're going to go to the second set. Excuse me, we're going to go to what we wrote down and ask it, do you belong to the second set? And if you do, we're going to cross you out. So let's start with the letter P. Does P belong to set B? It does not, so we don't cross it out. Does Q belong to set B? It does not, so we don't cross it out. Does R belong to set B? It does. We are literally taking away anything that belongs to B. The element R belongs to set B. And since we're taking away elements of set B, goodbye R. What about the S? Does it belong to set B? It does. We are removing the elements from set B. So we're removing the R, we're removing the S, and we're removing the T because it also belongs to set B. Whatever is left over is your answer. A minus B is the set containing P and Q. Let's try it again, but this time let's do it with B minus A, and I'm going to draw a line to separate the left problems from the right problems. Okay, let's try B minus A. Remember, to calculate a set difference, the first thing you want to do is write the elements of the first set. So we want to write the elements of B, which are the letters R, S, T, U, V. Then, one at a time, we want to ask each letter, do you belong to set A, since that's the second set? And if it does, we cross it out. Does R belong to set A? I'll highlight set A up here just so it's easy to find. Okay. Does R belong to set A? Yes, it does, so we must get rid of it. Does S belong to set A? Yes, it does. We must get rid of it. We must subtract it away. Does T belong to set A? Yes, it does. We get rid of it. Does U belong to set A? No, we do not take it out because it does not belong to set A, the one that we're removing. Does V belong to set A? It does not, so we do not remove it. So who's left? U and V. And if you notice, this is a completely different answer than we got for A minus B. I have a challenging question for you. You'll notice in both A minus B and B minus A, we crossed out the same letters, R, S, and T. How are those letters related to A and B, sets A and B? Look closely. The ones that we crossed out happen to belong to the intersection, which makes sense because if we're starting with one set and crossing out the letters that belong to the second set, then those letters must belong to both sets, and therefore they belong to the intersection. So you can almost think of it as writing a set and then taking out anything from the intersection. All right, I invite you to pause the video and try A minus C and C minus A, and also B minus C and C minus B. And in each pair, you should cross out the same letters. All right, I'm going to go ahead and do them. If you're planning on pausing the video, you better do it right now. All right, for A minus C, we're going to start by writing down everything in A since it's the first, P, Q, R, S, T. And then from that, we want to cross out everything that is also in set C. So let's highlight set C, make it a little bit easier to find. Okay, let's cross out anything that we just wrote down that is also in C. So let's check one letter at a time. One letter at a time. Is letter P in set C? Yes, it is. Is the letter Q in set C? No, it is not. Is the letter R in set C? Yes, it is. It's right there. And since we're crossing out things that belong to set C, we're going to cross out the R. Is the S in set C? It is not. We do not cross it out. Is the T in set C? Yes, it is. And so since we are crossing out the elements of set C, we cross out that guy. And who does that leave us with? That leaves us with Q and S. Did you get that? I hope you did. Now let's try C minus A. This time we start with set C. P, R, T, V. And I know exactly what I'm going to cross out. based on the earlier observations, we have to cross out the same letters regardless of the order that we do the subtraction problem in, because we're subtracting the letters that they have in common. But if I didn't do the first one, then I would have to do it from the beginning anyway, so we might as well. Does P belong to set C? Yes, it does. We are removing, I'm sorry. Set C is what we're starting with here. See how easy it is to make a mistake if you're not careful. Doesn't matter how good you are. We are taking away set A. That's what we're subtracting here. So the question I need to ask each letter is, do you belong to set A? And if you do, I'm going to cross you out. P belongs to set A. I cross it out. Excuse me. All right, so we're going to cross out P because it belongs to the set that we're removing. It belongs to set A. Is the letter R in set A? Yes, it is. Since we're removing set A, we cross it out. Does the letter T belong to set A? Yes, it does. And again, since we're subtracting A, we're taking away everything that belongs to A. Is the letter V in set A? It is not, so we do not remove it. The only thing we're left with is the V. But if you'll notice, we did cross out the same three letters as before, which happens to be the three letters that are in common to A and C. All right, let's move on to B minus C. Again, I hope you did these on your own, because anybody can watch somebody do math, but math is not a spectator sport. All right, for B minus C, we're going to start with the first set, which is B. So we're going to start with R, S, T, U, and V. And we are removing set C. So we're going to ask each letter, do you belong to set C? R, do you belong to C? Yes, you do. Since we're taking away C, the R is gone. There's only one other, I take that back, there are two other letters we're going to take away. The T, it belongs to C. And the V, it also belongs to C. So T and V are gone. That leaves us with S and U. Did you get that? I hope you did. For C minus B, we're going to start with C. So we're going to start with P, R, T, and V. And from that, we are going to cross out anything that belongs to B. So which of those letters belong to B? R belongs to B. T belongs to B. V belongs to B. In other words, the three letters I crossed out are all in that set right there. And it's not a surprise either, because those are the same three letters I crossed out in B minus C. And what does that leave us with? It leaves us with just P. Now, you don't have to write it one set and cross out the letters to figure out the difference. You can do it visually. You can look at set A and say, if I threw out the letters that belong to set B, that would be R, S, and T. I throw those out, I'm left with P and Q. There's my answer to A minus B, et cetera, et cetera, et cetera. But the visual way is to write the first set and then cross out anything that also belongs to the second set. A couple of more things to wrap up this video. First off, I need to fix this typo. All right. Just like union and intersection, I want to look at this from a Venn diagram perspective. And since we haven't gotten to 3 circle Venn diagrams yet, we're only going to look at 2 sets, A and B. Now, you may notice that these are the 2 same sets that we had in the previous video, in the previous examples. Set A contains the letters P, Q, R, S, and T, and set B contains the letters R, S, T, U, and V. And I also put them in the context of a universal set. P, Q, R, S, T, U, V, W. Because when you have a Venn diagram, you've got space outside your circle where other things might live, and you won't know what those are without the universal set at hand. Okay. Now, since these are the same A and B as before, then A minus B was PQ and B minus A was UV. We can go back and check that real quick. A minus B was PQ. B minus A was UV. So we're assuming that we've already done those problems. Let's drop everything in the Venn diagram where it belongs. In preparation for a couple of sections down the road, or is it the next section? In preparation for section 3, The regions in this Venn diagram, I've been kind of casually calling the football in the middle. There's a left moon over here, there's a right moon over here, and then there's the rest of the universe. But as we move forward with 2 and 3 circle Venn diagrams, we're going to need more descriptive ways to describe these regions. And so I'm going to start numbering them the way that they're going to be numbered from this point forward. This Venn diagram, this 2 circle Venn diagram, has 4 regions, and I'm going to number them using Roman numerals. The first part, the left moon, if you will, I'm going to call region 1. The football in the middle, I'm going to call region 2. The right moon, do y'all see the moon I'm talking about? It kind of looks like that. The right moon is we're going to call region 3, and the rest of the universe outside of the sets we're going to call region 4. This is going to be standard as we move forward. All right, so let's start dropping all the letters in the Venn diagram and see if we can locate which region or regions represent A minus B or B minus A. In fact, I challenge you to ask yourself, which of these regions do you think represents A minus B? Remember, A minus B means that we start with region A and we take away anything that also belongs to region B. So you may already know what is going to get shaded in. But let's put all the letters in here, starting with the letter P. Where does the letter P belong? Well, the letter P is in the universe, of course, but it's also only in set A. So where do we put letters that belong to only set A and not set B? What region? That would go in region 1. Oops, hold on. Region 1. What about Q? Well, Q is in the universe, of course, but it is also only in region and set A. So the Q will also go in region 1 because it belongs to circle A but not circle B. And the same thing for the R. The R, of course, being in the universe, but also being in only set A, needs to go in region 1 because region 1 is the one that belongs to circle A only and not circle B. I stand corrected. R is not just in A. Shame on me. Hold on. R is not only in A, but it's also in B. So it won't go in region 1. Where will it go? It must go in region 2. Because that's the region that belongs to both circle A and circle B. Who else is going to go in the middle in region 2? Who else belongs to A and B? The answer, S and T. My highlighting's not doing too well right now. So R, S, and T are the elements that will go in the middle because the middle represents the intersection. What about U and V? U and V, of course, being in the universe, also belong to set B but not set A. And if you belong to set B but not set A, which region do you go in? You go in region 3. U, V. That leaves us one element of the universe that belongs to neither circle. So that W goes out in region 4. All right, so now that we've got the elements of the universe, set A and set B, in their correct regions, we might want to double check to make sure everything is what we think it is. The universe should contain the letters P through W, and it does, the universe being the whole rectangle. Circle A should contain P, Q, R, S, and T, which it does. Circle B should contain R, S, T, U, and V, which it does. All right, so now that we have correctly represented each element in this 2-circle Venn diagram relative to the 4 regions, now we can identify which region or regions represent A minus B and B minus A. How? Because A minus B were the letters P and Q only. And which region contains P and Q? region 1. B minus A contained U and V. And which region contains U and V? That would be region 3. So now we determined which parts of this Venn diagram represent a set difference. A minus B is the left moon, or the moon that is part of A, and B minus A is the moon that is part of circle B. All right, one last thing before we move on, I want to draw arrows from here to here and from here to here. That's actually not where I wanted the arrows. I wanted them from the differences. All right, by the way, do you remember what the middle was? Region 2, where the circles overlap. In other words, where the circles intersect. It's the intersection. All right, so we got some pretty clear definitions for these regions. Region 1 is A, let's put colons. Region 1 is A minus B. Region 2 is A intersect B, and I can't type an intersection, so I'll type it in. Region 3 is B minus A, which kind of makes me wonder, what is region 4? Let's draw in that intersection sign. All right, one last thing. I want to take one more perspective of A minus B. What you see here is the set builder definition for it. A minus B is the set of all x's, such that x is an element of A and x is not an element of B. Well, we're going to do a little bit of smoke and mirrors here. If you are not in B, then you are outside of B. And if you are outside of B, by definition, that puts you in B complement. Remember that? Complement are the things outside of a set. So if you are not inside the set, you are outside the set. And the word and means something. And means intersection. So we could redefine this as A intersect B complement. So I claim that the set difference A minus B is the same as doing A intersect B complement. We'll actually verify that when we get to the next chapter about using Venn diagrams to solve problems. But we have two more sections or two more videos in this section.